Hello guys, welcome back to Programming Programmer. So today we are going to see a amazing problem called rearrange array alternately. So don't worry, I'll link this problem in the description box so you can find it there. So let us understand what the problem is. So the problem says to us that we are given an array which is sorted array. So initially let us say that we are having array like 1, 2, 3, 4 and 5. So we are having our array elements like 1 2 3 and 5, and what we need to do is we need to rearrange that array in such a way that the output that we are going to get after rearrangement should be like, let me just show you the output, then you will get the problem much clearly. So the output should be like here. For the very first element we should have the largest element from our array, which is 5. For the second element we should have the smallest element 1, then again the second largest element, that is 4, then second smallest element 2, then third largest element, that is 3. So what we are doing here is we are going alternately. Like for very first element we will just place the largest element, and then after that alternately we are placing the smallest, then alternately second largest, then second smallest, and likewise we are going. So this is the basic thing that we are doing in this problem. So the time complexity that we are aiming for this solution, or the solution of this problem, is order n, and the space complexity that we are aiming is order 1. So I have made a video previously with order and time complexity and order and space complexity. You can see that I link it in the video. I link it in the description box as well, so you can find it there. And the thing that makes this question really good is order and space complexity. So doing this in order and space complexity is simpler, but doing this same question in order 1 space complexity makes it a little bit difficult. So let me just tell you what happens here. So to do this problem, there is a very beautiful concept that is which we have to see. Okay, so that makes this concept makes this question a really beautiful one. Okay, so what we are trying to achieve is, let us say we are having an array like 1 2 3 4. So 1 2 3 and 4. Now I say you that you need to rearrange this array, but while rearranging you cannot take extra space. So while rearrangement, very naive approach that we come up to is that we have to save we have to save both the values. Like we are having this value here as well as the new value that is going to be here, we should save it here. Okay, so like we are having 1 here, and we should also have 4. Okay, so these are the new value as well as the old value. If I am able to somehow do this, okay, so this is the basic intuition behind this. If I am able to somehow do something like this, that I am able to save the new value as well as old value in place of every value. Like for here the old value will be 1 and new value will be 4. For this one the new value will be 1 and the old value will be 2. Okay, so if I am able to do something like this, then I can easily solve this. So for this you would say that we should use pair, or we should use some data structure, but that is not allowed. That will just take the order and space complexity, so we cannot do that. So we need to do something else to achieve the same task. So for that what we are going to do is we are going to use maths here. Okay, so let us see what maths are we going to use here. So as maths we are going to use a simple formula, that is dividend equal to divisor into quotient plus remainder. Sorry. Okay, so you must have come up across this formula once or twice or many a times in your lifetime until now if you are viewing this video. So this is a fairly simple formula. If you don't know about this, then I am going to link it in the description box so you can get a more clarity about what this is. Okay, so let me just briefly tell you how we are going to use this. Okay, so let us say for every element I have a divisor. Okay, I have stored a divisor. Okay, no questions asked, just try to listen what I am saying, then you will definitely get it. Okay, just assume that for every element you are going to have a unique divisor. Okay, like for this I am having some divisor x, I am having some divisor y, I am having some divisor z, and something else for this one also. Okay, so we are having some divisors here. Okay, I am really sorry, that is not divisor, that is dividend. Okay, so we are having some dividend, we are aiming for this value. Okay, so we are having some dividend for all the elements in my array. Okay, now what is the case? Likewise, I also know the divisor for all these elements. Okay, if I know the dividend and divisor, then what can I do is, if I do dividend modded by divisor, then what I will get? I will get remainder. Okay, if I do dividend modded by divisor, I will get remainder. Okay, you must be clear about this. And if I do dividend divided by divisor, then I will get quotient. This must be clear. Okay, if I do dividend modded by divisor, then I will get remainder, and if I do dividend divided by divisor, then I will get quotient. Okay, so this is the exact thing that we are going to use here. Okay, you can see that for the particular dividend and divisor, I am getting two different value with two different operations. Okay, so these value will be consistent. Okay, so now how I am going to use this? Okay, I am just going to use this let us say that for quotient, let us say that our remainder represents old value, and let us say that our quotient represents new value. Okay, so what I mean by old value and new value? Okay, so let us say for this array, the old value is 1 and the new value is 5. For this, old value is 2, new value is 1. Similarly, for this, old value is 3, new value is 4. And along that, we can go with these also. So we know the old value and new value regarding all these things. So what I am doing is, I am just saying that remainder will represent old value and quotient will represent the new value for particular dividend and divisor. Okay, so now we are getting a little bit intuition how we are going to solve this. Now what should be our aim? Our aim should be, we should have different dividends for all these elements, but we should have same divisor. If we are able to do that, like we are having same divisor for all these elements but different dividend for all these elements, and then we are going to get remainder and quotient respectively for them, which will represent old value as well as new value, then our whole problem will be solved. Okay, so if we are able to compute our dividend in less than order n time or order n time, then our algorithm will be running in order n time only. Okay, so you can get that by basic knowledge of like how time complexities works. Okay, so now what I am going to do is, I am just going to see what my dividend should be. Okay, to say what my dividend should be, I want you to look upon a property of modulo. Okay, in modulo arithmetic, we see that if we are doing a mod b, then while doing a mod b, the range of values that we get are between 0 to b minus 1 as a result. Okay, so it will always lie in this range, right? So this is the value that we get when we do a mod b. Okay, so you must be knowing this. If you don't know, then just remember this by here. Okay, or else you can see regarding this also on internet. Okay, I'll just link it also in the description box regarding modular arithmetic. Okay, so you can get more insight in this. Now let us see what I am trying to say. So what I am trying to say is, we are doing dividend mod divisor here. Okay, so I want a consistent divisor for all my elements. So what divisor should be? That divisor should be such that when dividend will be modded by divisor, then for different dividends we should cover the range of elements in a sorted array. Now to cover range of elements in a sorted array, one thing is clear. If I am targeting for the maximum element, like the maximum element in this array, then I am going to cover this range. Okay, then the maximum element in the sorted array is the last element of that array. Okay, so the last element here is 4. Okay, now what I am going to do is, if I just say my divisor is 4, then it will not do it for me. What I need to do is, I need to increment it by 1. So I will do divisor equal to a. Let's say our array is a, and divisor will be a of n minus 1 plus 1. Okay, so my divisor is a of n minus 1 plus 1. I think you are getting intuition behind why I am taking my divisor like this. Okay, I hope this must be clear by now. If not clear, just go a little back in the video and you will definitely get it. Okay, so I took my divisor like this, a of n minus 1 plus 1. Now what I am going to do is I am just going to do this thing. Okay, now let me just come to the basic algorithm that I am going to use here. So what I will do is I will just take two variables. I will use one variable as minimum index. Okay, and it will be 0 initially, and the another variable will be maximum index, and it will be n minus 1 initially. Now what I am going to do is I am just going to run for a for loop, and that loop will run from I equal to 1, I is less than n, and I plus plus. Okay, now inside this loop what I am going to do is I am just going to check whether I am at even term or odd term, because that will matter, because for the even terms what I want is I am concerned regarding the maximum index. Okay, and for odd element I am concerned about minimum index. So this is 0, 1, 2, 3, 4. Okay, so I am concerned about even and odd, so that I can divide these values among themselves. Okay, so I hope you must be getting this. So what I'm going to do is, okay, one more thing, I'll start with I equal to 0, not I equal to 1. So that's a mistake, please correct it. Okay, so for I equal to 0, I is less than, and I plus plus, what I'm going to do is now I'm just going to check if I is even, if I mod 2 is double equal to 0, just like I'm going to just check it. And if it is even, then what I'm going to do is I'm just going to write it in the form of dividend equal to divisor into quotient plus remainder. So I want my element to be the dividend. Okay, so what I'm going to do is I'm just going to write here a of I, which is going to my dividend. Okay, I'll just write it equal to divisor, so my divisor is d. Okay, I've saved it above. Dividend equal to divisor, I'll multiply it by quotient. So what my quotient will be, so here my quotient will be the new value. Okay, and the new value should be, the new value, let's say for this will be the maximum element. Okay, so it will be pointed out by the maximum index. Okay, maximum element for that. So what I'm going to do is a of, sorry, my bad, a of maximum, please don't mind my bad handwriting, a of maximum index. Okay, modded by. Okay, now we want quotient. So for quotient what we are going to do is we want the old value at maximum index. Okay, so the original value at this will be the remainder. Okay, so I want its remainder to be quotient here. Okay, so what I'm going to do is this a of maximum index modded by d. Okay, so this will be my quotient. So dividend equal to divisor into quotient. So we are here. Now what I want remainder. So for remainder what I want is, for remainder I want the old value at a of I. So old value of a of I is a of I itself. Okay, so what I'm just going to do here, I'll just going to write here a of I. Okay, so this will be when I is even. Let's assume that my I is odd. So I am just doing this in if. Now I will come to else, and when I will come to else, now in else what I'm going to do is I'm just going to write a of I. Yeah, one more thing, when the if block is like when I did this operation, what I'm going to do is I'm just going to decrement my maximum index. So my maximum index will be maximum index minus minus. So I will decrement my maximum index by 1. What now for else what I'm going to do is I'm just going to take a of I equal to dividend equal to divisor into what my quotient would be. My quotient will be a of minimum index a of minimum index, that is I actually, okay, modded by divisor. Okay, now what I will do is I'll just plus a of I here, so it is similar to the above one, and here also I will just do minimum index plus plus, so I'll just increment by minimum index by 1. Okay, so this is how my whole array will be rearranged. Now my array is containing what? My array is containing modified values, but at the end what I will want is I want it to have new values. So to get new values, what I will do is I just run again a for loop, and in for loop I'll go similarly for I equal to 0, I is less than n, and then I plus plus. Okay, I'm just going to do this. Now after this what I am going to do is in this for loop I'll just do one thing, a of I divide equal to, so this is a shorthand operator, a of I divide equal to d. So what it is doing, it is just doing a of I equal to a of I divided by d. Why am I doing this? Because here is the key to that, like dividend divided by divisor equal to quotient, and quotient is the new value. So I'm just aiming for the new value that will be at ai. So this is how this is done. Okay, I hope now you will be able to code it, you will be able to get the concept behind all these things. Okay, so I'll also link my solution in the description box, so you can also use that, you can also refer to that if you are not able to code it till now, but you will be able to code it. Okay, so that's it. Thank you, and if you like my content then do like, subscribe and share.